Good afternoon, class. We are now going to do another problem that involves a nameplate and the actual voltage of a circuitry. Right here, we look at this drawing, we see that that is the actual voltage of the circuit, and we look down here and we have the nameplate rating. The nameplate rating of all of these different devices. Now notice this is a pictorial drawing. This is a picture of the drawing. And this down here is the schematic of the drawing. Okay, we're going to get right to it. Move on to the next one. I'm going to show you again. The first thing you should notice is that the voltages, you got 240 volts here, and 220 volts here, 230 volts here, and 250 volts here. You should notice that those voltages are different. Again, this is a parallel circuit, so that's that. And then the next thing we see here is that these voltages are not equal. These voltages are not equal. So the first thing we want to do is we want to calculate for resistance right here. This is what we want to do. And so that's what we're going to be doing next. What we're going to do here with that particular problem is we're going to solve these three problems right here. The first problem says figure 119.1570 shows an equipment layout in a laundromat. The current drawn by the shirt press is blank amps. We want to find out how many amps is being drawn by this shirt press. Okay, so the first thing we want to do is go to the shirt press screen. And the first thing we want to do is we know that the shirt press has a wattage of 1800 watts. We know that the ESP, which is the nameplate, is 230 volts, and so we can find resistance by using the formula E squared over R. We plug in our values here, we plug in our values in the P, and our resistance is 29.38. Now, in order to find the current of that shirt press, we must use the actual amps. Do not use the nameplate amps. Use the actual amps. We take the actual amps and we divide it by the resistance, and that gives us 8.16 amps. That's the first question. The second question asks us, says in figure 119, the same figure shows an equipment layout in a laundromat. The total current drawn by all the loads is blank amps. Now what we must remember about all the loads is that all the loads, all three loads are in parallel. So that tells me in order to find the total current of all the amps, I must find the resistance of all the loads. And once I find the resistance of all the loads, then I can find the total amperage of the parallel circuit. So let's go to the wash machine. I've already showed you the shirt press. Let's go to the wash machine. This is the wash machine circuit. It gave me 7.2 amps at 220 volts. So I can take those amps and the nameplate rating of the particular device and to find the resistance. Once I find the resistance, then in order to find the amperage of that piece of equipment, I must use the actual voltage. So the actual voltage divided by the resistance of the equipment gives me 7.85 amps. That is the wash machine. So we already did the shirt. I'm going to show you the shirt press real quick. Here's the shirt press one more time. That's the shirt press. We know we got 8.16 amps. And now I'm going to give you the what is that thing? CD. I forgot what that was. Let's see. CD is the clothes dryer. Sorry about that. So the clothes dryer gives me a wattage of power, a wattage of 5,000 watts. I know that my nameplate voltage is 250 volts, and so once I do the calculation for resistance, the resistance is 12.5 ohms. Now, in order to find the amperage of that particular circuit, I must use the actual voltage. I'm going to take the actual voltage and divide by 12.5 ohms, and that's going to give me 19.2 amps. And so once I have done that, now I can find the total. Amperage. I take the total amperage of the wash machine, the total amperage of the shirt press, the total amperage of the clothes dryer, add those together, and I get 35.16 or 35.22. One of the things that I wasn't very careful in is I did not round up appropriately. So because I didn't round up, my numbers are a little bit off. But anyway, just make sure you do your rounding correctly and you should be fine. That takes care of the next question. Last question, guys. It's question number 30. It tells us to use the same figure, 119.570, and it says that it wants us to find the total power supplied to all three loads. Now, there's an easy way to do this, and of course, there's a hard way. Now, of course, we did find the total. We found power in every single one of our calculations. If you look back at the notes, and I'll just go through them real quick. We found the power for each one of those, if I'm not mistaken. Let's see here. Maybe we didn't find the power. I don't see it, but here's the total power for each one of those calculations. So you can go back and find the power of the wash machine, shirt press, and the clothes dryer, add them together. Of course, be mindful of rounding, and that'll get your answer. Or you can look at the answer you got for the total amperage multiplied by the total voltage, and it gives you this number. That's the easy way of doing it. But if not, you will have to go through each and every one of these nameplates and find the power. Okay, find the power. I don't see my calculations on the power. Let me stop the video.